In the Buzz Robot Talk today, our guest Ilan Bigio from OpenAI will discuss different approaches for autonomous agent orchestration.
Yeah, and we're going to talk a little bit about just the different insights we gathered while developing, like exploring Swarm, and everything building to it. I do want to start by saying, Swarm is not like a production framework. It was more meant to like gather learnings, exactly like the ones we're going to present, or I'm going to present today. So that's kind of just a quick introduction. A little bit about me. I joined OpenAI roughly a year and a half ago. Before that, I was an engineer um, for 3 years. I joined OpenAI. I was a solutions architect for a year, and that means I was working directly with companies that were shipping products to production with AI and sort of helping them through that process, either consulting or writing prototypes and helping them actually get traction. So um, in that team, I had a lot of experience being able to see like what actually works in production, the different approaches that companies are taking, and the whole idea behind this talk in Swarm is which parts of those, like what is the taxonomy, just organize all of those ideas for agentic systems and this sort of like orchestration. Just to get started with that, uh, let's take a look. So the four general categories we're going to talk about today is patterns, abstractions, and trade-offs. Reliability versus capability, which is one of the main trade-offs. Understanding the bitter lesson, and then just primitives and interfaces that we explored and are relevant to pretty much any framework that has to do with agentic systems. First off, patterns, abstractions, and trade-offs. Everyone, it seems right now, is making their own agents, right? We have Sierra, Klarna, Devon, all these different companies. Some of them are building the actual applications that are using the agentic frameworks, and then some are developing the frameworks themselves. But a lot of the techniques that we're going to talk about today actually apply on both ends, regardless of whether you are building the actual application that will go into production or the more fundamental techniques that make up the framework. So patterns and abstractions are fundamental to powerful and reliable systems. I want to start with an example with Klarna. So just to get a grounding for the context here, Klarna was able to ship a customer service solution that replaced a like large amount of effort and investment and increased user satisfaction significantly. And this was like a really like great sort of example of these orchestration techniques in action. Here is the solution that we worked on together at a very, very high level. I want to quickly walk through it because this will be codified. This essentially started the whole process of the explorations that we did later. So the solution we came up with is we have a couple tiers of routing. The first tier uses a smaller model to determine what the right like category is, or like what the right agent is. And then as tier two, we have multiple different agents that are specified to handle different categories, such as returns, such as any form of support, separated by region. And so after these two structures, we have a knowledge base and we have routines. And we'll get into what routines are in a second. But in short, when a user makes a request, it goes through tier 0, gets routed to the right agent. Tier 1 will determine what the right routine is to interact them with. If possible, take it all the way to resolution. And if not, it'll escalate it to a human, and there'll be some review. So I just want to lay the groundwork. This is one example of something that is in production right now that serves like many, many customers. So I want to use this to seed the rest of the talk. So how was this done? Well, when developing these approaches, there was, or when developing like the approach with Klarna, there's a lot of exploration. It's like what was actually going to be a practical solution. Here are some of the abstractions that were considered. So we have routines, we have chaining, workflows, language model programs, we have handoffs, manager, orchestrator pattern, agent decentralization. Let's talk a little bit about what each of these are and how they play into actual systems. So first one, routines. This is what you saw in the diagram. It's very, very simple. It is really just a list of steps in a prompt. It's extremely simple. There's loose adherence because you have these like steps that are described in the prompt itself. So there's no like actual guarantee except the model following the instructions. However, it's shockingly effective, right? Like as you have a conversation, you'll go back and forth. Models will usually tend to follow this quite well, up to like some like balanced number of steps. As part of routines, it's often included functions themselves. And so a routine, we've sort of arrived at the definition of a set of steps plus the functions required to perform them. And it's a very, very simple idea, but it turns out to be very, very powerful in practice. And this has made one of the fundamental bases of the Klarna approach. Um, Another one, a little bit of a step up, is chaining. This is like sequential, non-branching steps. You take something like a query, perform a few steps on it, and then get the result. Still simple. You have strict adherence now because you have all these like very regular testable steps, and you're trying to model a process. A lot of companies like Langchain try to formalize this, but in essence, this could be described in many different ways. You can have Python. This is where things start to get a little bit more powerful. Now, workflows is where things start to get significantly more powerful, because you start to describe these like graphics, like highly controllable graph execution branching steps. Now, what differs workflows from the next one that I'm going to talk about is the specific work nodes in each of them are prompts themselves. And the decision points, the conditionals, are still described in your usual code way. So you have these like semi-deterministic systems that have these LLM components within them, but the actual branching and the actual decision-making portions are still controlled in code. Moving on, we have language model programs, which is very, very similar to a workflow, except the actual decision points are being made by the model itself. This is a very, very powerful construct. This is what many people would describe as agentic. And kind of looking back at these, I'm picking some like formalized names for them, but you will almost certainly have seen these in many, many different names or without names at all. This is just trying to capture these ideas. Yeah, this is what people might consider agentic behavior. It is less controllable and you have higher variance because these steps are being made by the model, but you get a lot of power and expressibility when you take these approaches. All those techniques were sort of for single prompt setups or single execution setups. If you want to have this idea of like multiple agents working together, you might have something like a few different coordination techniques. We have handoffs, where a conversation is handed off entirely to a different assistant, and the system prompt is swapped out. Manager orchestrator, where you have like tasks being passed around, and the decentralized approaches, and you've seen this in like slightly more like simulation, like world scenarios where agents are let to like talk with each other and there's like incomplete information to kind of and swarm lands in the handoffs. So to kind of put a pin in these ideas is the building blocks that you choose are pretty important. But they don't have to have a pre-existing name, right? Giving them a taxonomy, giving a bit of an overview is useful because it lets you think about these a little bit more precisely. However, there's probably some I missed here. And you might know these as something with different names, but the idea is these are all describing different ways you can orchestrate your systems. The reason in Swarm we ended up eventually going with handoffs is because of the simplicity of it. All the other systems were quite complex, and we weren't in the market for making like a huge production framework. We wanted to see what was like the simplest form that could describe an approach like Klarna. And so if we look back at the approach in Klarna, the way that the tier 1 and tier 2 distribution happens is through this sort of handoff approach where the system prompt is changed, the conversation is maintained, and you have this essentially like passing conversation between different agents. So kind of wanted to cover like the base techniques when we think about orchestration. Now, thinking of these companies and what we've actually done in production, let's look at some best practices. So the first one is keep it simple. I show you a lot of different examples, but oftentimes the simplest is the best, is what we've found. A single system prompt with good functions, which is you could describe as a routine, is often all you need. The next one is express logic with code. This is kind of what more the workflows look like. If you have well-defined workflows with conditionals, you can already express quite a lot, and you're not losing that repeatability that you often do with language models. If each of the steps might be non-deterministic with a language model, but the decision points are made by you with heuristics, you end up with like highly dependable systems, maybe a little bit less expressive and powerful, but in practice, they're going to be very effective. Number three is make tasks constrained. And as constrained as possible if you can. You want to make it easy on the LLMs to perform what you want. And so you want to spell out tasks step by step, highlight edge cases. This is usually a very iterative process. But what we find is if you ask a lot of a language model, it might be able to do it because they're very powerful. Maybe like 2 or 3 out of 5 times. But every now and then, it might not do exactly what you want. And so constraining what you are actually asking from the model at each step is what we found gives the best, most consistent results. Number four is focus on frequent user journeys. What I mean by this is if you think about a specific case, like a specific use case, maybe like an email client, um, you might want to build out like this solution that solves for every single case you can think of, right? So you just want to make like a search, and like if someone can search for like find all my flights, find what these events are, answer these questions, and so you generalize the problem, right? Which is often what engineers do, right? We take like specifics and generalize it and try to solve the generalized problem. Um, that is sometimes useful, and usually in computer science, it is a very useful practice. But with large language models, actually testing for all of those cases when you don't have this um, like coverage of every single case is harder than you think. But catching each of the cases that you really care about and doing them well is easier than you think because there's often fewer than you think. So in the email case, maybe you want to make sure that um, people get like they're able to search for questions involving summarizing emails in a specific range, answering specific questions about dates that are found in like individual emails, and like surfacing flight information, right? Maybe there's like the three user journeys that you decide to focus on. You can make those really, really great, and that'll cover 90% of your cases. And then maybe the 10 or 20% that are left over, then you try to have the generalized solution for. But you got to think about the distribution of effort that you're putting in and how much you can actually squeeze out. And then the last one is build for your application's acceptable failure rate. So this is a really, really important point that I'll be getting more into later. But more forgiven use cases can tolerate less constrained strategies, such as the language model program approach and the like orchestration decentralized approaches. And so if you think about this, a case like ChatGPT is a great place to explore, more of these like agentic behaviors because it's a very interactive use case. And it is often you have some expectation of retrying and guidance, right? But if you are making this part of a product or making this part of a very strict flow, you don't have that much flexibility. And so if there's any mistakes, you can't really guide it because there's no human in the loop. And sometimes even when there is a human in the loop, they might not have the patience to actually want to interact. So it is really sensitive and important to determine what your like application's acceptable failure rate is. And if it's low, then stick to more deterministic setups as with the first ones we covered. And if it's very high and very exploratory and users are excited to like get these more powerful results, then you can go for slightly more unpredictable yet powerful and expressive systems like these like multi-agent setups. These are the ones today, but they may change tomorrow, right? As the models evolve, it's important to keep in mind that the status quo evolves and like the advice that you have to listen to also evolves. And so while some of these principles are I try to make as like stable as possible, you always have to stay in touch with, maybe there's some advancement that makes it so one of these points no longer matters. So you got to stay on top of things. Patterns and abstractions need to be used in the useful. They have to be built in the for the real world. And so this is kind of going back to the example that we went with Klarna. If you take these examples, have them work in principle or in experiments, that's really cool. But if you really need to apply them to the real world in order to test out and see if they work and get the feedback. And that is, skipping ahead a little bit, that is what we did with the swarm approach. Is we would test it out with multiple different interested parties to see what feedback they had, where it fell short, where they felt it excelled. And having this like tight iteration loop is what we find is really key. So now let's talk about reliability versus capability. Some use cases should not be exciting. And this is a little bit of a maybe like a downer or shock to hear, but it's like this kind of goes to like the acceptable failure rate point, right? Some use cases should be so simple and easy to understand that that the customers won't be upset because it's not performing what they want. Systems are often built on this sliding scale between reliability and capability. Like more reliable systems are usually more hard coded, have more like heuristics and handcrafted techniques, and are quite reliable. However, they might be more limited in what they can accomplish and don't generalize quite as much, right? Here you have, like existing workflows or anything you might write in code. However, on the other end, you have like these really capable, like just agentic free systems that you just essentially give it a prompt, give it access to a bunch of models, and just let it run. And you might like hook up many different systems and like, but each of the parts that you had, usually with the more power, comes a little bit more instability. And so you often have to decide where on that scale your use case will land. Yeah, we sort of covered the like if you have more interactive applications that have non-destructive actions like search, like things in ChatGPT where you are not actually affecting any state, then it's great, right? You want these sort of like you want to be surprised every now and then by how capable it is. However, if you have destructive cases, if you have anything that's managing a system or taking actions in the real world, you might want that to be more reliable if those actions can't be retried. And so you should you might want to consider going to like workflows or less expressive systems. Cool. So this part I think is pretty important. Understanding the bitter lesson. Never bet against deep learning. This is a lesson we've learned time and time again. Just to start off, a few examples are, image recognition. We had like a few different like handcrafted techniques and like features that were eventually gobbled up by convolutional neural networks. In Chess-Go, we had like minimax algorithms and other heuristics, and like that was like state of the art. And then we had like all these like professional like grandmaster chess players like crafting these techniques, and then we had like a pure RL self-play system that just like gobbled that up, right? Speech recognition was the same. We had phoneme models, linguistic rules, and then Whisper was an end-to-end trained system. And like finally with like natural language processing, we had these like task-specific models, also linguistic features, and then transformers and GPTs came around and like showed that we could model language much better without these handcrafted techniques. And so this is all just like to try to viscerally convey the idea that like deep learning will usually take any system that is highly complex, that has a well-defined input and output, turn it into a like deep learning will come and improve upon it. And all these like complexities and like handcrafted techniques that we had will often be replaced by these like end-to-end systems. How do we respect the bitter lesson? How do we keep it in mind? When it comes to autonomy, it's important to consider how the bitter lesson or how deep learning might apply here, right? The best autonomous agents will likely come from end-to-end training, right? I don't think this is a very controversial idea. I think this is what we've seen over and over again. Any of these techniques that like are very like opinionated in like how they coordinate systems might work great now. But who's to say that there is not a or I guess the pattern that we see in history is you have these handcrafted techniques that they then get essentially learned and absorbed by these more end-to-end systems. However, these end-to-end systems are more powerful, but often more opaque, right? Like with all the examples that we saw before, we had some understanding how they worked before, and then we had essentially zero understanding. They were more powerful and they did what we wanted, but we didn't have that understanding of how. In game scenarios, it might be fine, but in agentic scenarios, it might be a little bit, it might be very important to understand why certain decisions are being made. Many use cases will still benefit from the fine-grained control. I think if we have something like a chess engine, we don't really care, right? Really, we don't really care that it's a black box and it's doing things how we want. However, if we have like more fine-grained systems, it might be very valuable to understand why certain decisions are being made and how to prevent certain decisions, or build in some guardrails so that you can have this transparency into the system. So the main idea here is you don't want to really get caught in this middle ground, right? Where your system is like very fragile, um, like very powerful but fragile, in that you have coordinated like multiple different pieces together delicately in this like fine dance of agents, right? Because if you think about it, that's exactly the type of scenarios that have often been replaced or learned by these end-to-end systems. And so systems that might still benefit are if you if these deep learning like end-to-end systems will improve your system, right? If you won't be upset that the intricacies of orchestration go away, then you're in a good position, right? That's what you want to strive for. Or on the other end is you want to go for like such simple, like repeatable, reliable systems that large autonomous systems will just not be in the same playing field, if that makes sense. You'll still be able to explain exactly what's going on, maybe through state machines, but a lot of systems that are like need to be highly repeatable and highly sensitive will for a very long time remain in that section. As we get closer to talking about Swarm, the last piece that we investigated was primitives and interfaces, and it was how do you express the ideas and concepts that you want in a way that lets people build on them with as much intuition as possible, right? So the first thing is nobody really wants to learn your interface. They just want to use it, right? You can't start off expecting people to be excited to dedicate time to learning this one thing that you built that they may never use again, right? You want to make it a ladder, and this is an idea from Sebas Benu that they have in their blog. But they describe APIs, ideal APIs, as this ladder where each step up, you start very low, where you're very accessible to everyone. But with each progressive step, you get a little bit more complex and you allow for more complexity. And all of these ideas will tie into how we design the different pieces for Swarm in a second. But the idea is you start with a low level API, and this could be thought of as close to what operating systems do, right? You have this low level API that works very close to the metal and is like as minimal as possible, right? And then you have this higher level API that uses it. Um, and a good API will expose both to the user, right? You'll have this higher level control that you might want to use most of the time. But if you really want to like dig deep into the details, you can also do so through a low level API. And so you're never trapped between being able to do the things that you want, which might be intricate and take more effort, versus exposing these like useful abstractions that actually give you a lot of freedom. Finally, getting to Swarm. I want to say again, it's not a production framework. It was just an educational, explorational example. I encourage you all to give it a shot, to play with it, and draw inspiration from it if you want to build your own production systems. It just happened to have a catchy name and a catchy logo, and so it sort of spread like wildfire. But the idea was just exploration. And so the main ideas are it takes all these concepts that we talked about and tries to select for the ones that prioritize simplicity, transparency, and reliability, right? So a lot of the like very complex agent to agent orchestration techniques you won't find in Swarm because they're less reliable and less transparent. The other thing is it was very important for us that we didn't just build this framework like broadly for any use case because we weren't striving for a framework, right? We were trying to formalize some ideas from real world use cases, and so we built it trying to see. The question we kept asking ourselves was, will this work for Klarna, right? Like could we have built Klarna on top of this? And we had to make sure that the answer was always yes. Um, and so very fortunately, we found that like the patterns that we use in Klarna were actually mapped to the swarm that is out today very quite nicely. You could rebuild one of their systems or a system quite like Klarna's in not too much time. Where when we were first discovering these ideas for the first time or like encountering these abstractions, it was unclear which ones to use and unclear how to structure them in an ergonomic way. Now it could be done much more quickly. And then the final idea is we started with a small core API And this would be like the low level API I discussed before, and didn't really build a higher level API. I think if we were going to make this a framework, that is probably something that we would want to consider. But we didn't, and we don't have no plans to do so. But it is a direction that if you are building a framework, would want to explore. So I think just to give an idea for maybe those who haven't seen Swarm, I want to jump into it and do a little bit of a live coding to show what it feels like and some of the principles that I particularly like about it. So the main idea is, let's see, we can just say from Swarm import agent. And so we wanted to make the syntax feel very familiar. So let's say we have an agent. We can just define it as such. We define an agent, and we have instructions, and we're technically done, right? We technically have a working agent that we can talk to, and we also have this utility called the run demo loop, and all this is it makes it so we have a nice little interface for it. So and we will have like streaming outputs. Okay, so let's see. I'll do cool. So now I have this, and I'm like, hi. Say hi to everybody. Cool. So I have this setup, right? It was quite simple to set up, and that's part of the idea of Swarm is, like I said, not really a full-fledged framework, but just like a very, very simple way to do things. Now, things start to get interesting when we decide to add functions. And so the way you would do this in chat completions is you would have to define your schema and then provide it to the model. Whenever the model calls a function, you have to parse this out, handle the function call, actually map like the schema chat completions function call to whatever function you actually implemented, parse it out, call a function, and then return the result to the model, and then call another inference, right? And it was just many steps. There's nothing interesting going on there. And so what we decided to do in Swarm is have maybe let's say like return, I don't know, send email, right? And so for now, I'll just do like a dummy email, a dummy function, and I will add this like print statement. Cool. So now I have this function that is very simple, takes a to, subject, and a body, and all it does is like prints the information and then returns sent. Now, what this was very, very important to me when developing Swarm was I didn't want to have to figure out how to supply this function. And so the way you can do this, pass this to Swarm, is literally just pass the function by name as a first class object, right? And so this already is one of my favorite features of Swarm, and I use it just for this when I'm prototyping, is just so I can pass functions and they get handled easily. And we take this this Python first class function and then convert it into this schema. Let me see if I can actually jump in and see how that's done and show you how that's done. I'll do that in a second, but I'll show you this first. So the idea here is I can now say no. Send an email, please. Send it to Sophia. I don't know if this is real, but and then subject is I'm loving this talk, and the body make up some poem. Right, so now it's calling the send email function, and as you'll see, it called with the right parameters and sent the little poem. This is a very pretty. Anyway, this is just a little quick example. Now, the spot and this is none of this is like super crazy. This is all like very basics still, but it's right now what I'm trying to show is just the simplicity of interfaces. Now, the next step I want to show is this idea of handoffs, right? Like, let's say I want to have another agent, right? Maybe one to actually interface with a user, and then one to actually deal with like anything email sending. I might want to make a second agent called like triage agent, and I'll say direct the user to the right. Right. And so right now they're not wired up, right? Like if I just start with the triage agent, it doesn't have any access to the other agent, right? I haven't wired it up. So the question is, how do we actually connect these two? And there was a few things we considered. We could set like a special field called agents that lets you like transfer to specific agents. And then there's a question of like, what does transfer actually mean? How do we represent that in the prompt? And so another goal in Swarm was transparency. And so one really cool detail is there are no prompts whatsoever in the Swarm core codebase. Everything is done entirely mechanically, including handing off conversations from one agent to another. And so I'm going to show you right now what that actually looks like. So we'll say, transfer to, email agents. And all I'll do is return. So Cursor really wants to call it email agent. That's fine. That's probably a better name. But the idea here is this is all I need in order to do a transfer. And so I'll supply this function to the triage agent. And now it has this transfer to email function. And so first I'll show you, right? I'll start off and say, hi, I want to send an email. Triage agent. Oh, and I guess I can just say, so I can say, use this function whenever the user expresses wanting to send an email. Right? And so this is the really cool part is you can customize the conditions. You can customize the conditions that necessitate like a transfer. So if I try this again, want to send an email. Transfer to email agent. Now I'm talking to the different agent, and I can say, make up all the fields for me, please. This is just a test. Great. So now it did it. And as you can see, we went from one agent to the other. I want to pause here, get back to the presentation, and probably open this up to further questions later because this is going to be very interactive. Just to conclude like this part of the presentation, here's a few key takeaways I would like you to take. So the main one is build for your application's acceptable failure rate, right? We covered this idea a couple times. Depending on how forgivable a use case is, you might be able to do more exploratory or powerful things or less. Oftentimes, you will land in the less side of things, but that's not always true, right? It's very important you figure out what it is for yourself. Remember the bitter lesson, expect autonomy and build for simplicity, right? You're going to get simplicity on one end or the other. Either it's going to be simple because it's a black box, or it's simple because you want to have very predictable, transparent systems. The weird middle ground of like highly complex, coordinating systems probably lands somewhere in a similar spot as previous like heuristic approaches with Go or image recognition. Expect deep learning to keep getting better is never bet against deep learning, I think is the lesson. Number 3 is keep abstractions simple and make them composable. Here, I showed you an example with a couple agents, but and as you can see, setting up 1 was very simple. Setting up 2 was pretty simple, but you could probably set up you could set up hundreds of agents coordinating between each other using the same principles, right? So if you keep them simple and composable, people will scale them as they please. And the last one is build for the real world. If you have like awesome ideas, you might want to, if you have awesome ideas you might want to like ship, make sure they're grounded in specific use cases and don't just stay conceptual. We did this with Swarm, always going back to, could this work for the Klarna use case? I think this is the end of this part. I'm happy to keep talking and go on more rants, but I wanted to keep this short so we can open up for questions and hop back into the code and poke around because I think people will probably have questions around that.
I see Jim was asking about abstract. In what sense is ergonomic intended?
In what sense is ergonomic? I think like
Mm-hmm.
friendly to use is how I meant it, right? So you can the example here is like, instead of um y- y- the fewer objects and new concepts that you have to give someone to learn, the simpler and more ergonomic it is to use. Like if you, I think my precise definition of it is like if your abstractions follow the way someone thinks, it's ergonomic, right? But if it requires them to change how they think about a problem in order to fit your tool, that's not ergonomic.
I see Jim has another question since we started with Jim. Jim, do you want to ask that question?
A couple problems that I've noticed with all the agent frameworks since AutoGPT from, I guess, more than a year ago now. Infinite loops where the context window isn't summarized hierarchically, and I'm wondering if there are any best practices for summarizing the context in a way that can prevent infinite loops. And what about mistakes made early on? Self-critique patterns that can challenge the assumptions made early on in an agent's decisions about how to go about things. Is there any work in that area?
Yeah, I guess I have two answers, right? Like one answer is the whole infinite loop paradigm, and just like making progress towards any abstract goal, kind of like AutoGPT, sort of lands in this like weird middle ground of like, this system isn't really made to be agentic. It's sort of kind of duct taped together from multiple different parts, which means it works, and often it works quite well. But there's no like great reason that it works. It's not really trained end to end to do so. And so to be more precise in the answer, it's like, what is the use case that you want it to succeed for, right? And see if like certain kinds of prompting will make it succeed for your use case. Because I think there's no general answer to like, how do I prevent errors early on to from propagating forward? Like I think we're gonna find a few interesting techniques that work in like some cases and maybe even most cases, and then we're gonna figure out how to do the whole thing end to end, and it's just gonna be much, much better, right? I think an example of this is like this reasoning paradigm. Um, we've been trying like all these different techniques, like prompting techniques and like like reflection and like all these like handcrafted techniques to coerce prompting from the models. There's things that work in general cases and not, and you could have asked questions like, how do you prevent the model from like derailing during its like reasoning chain? And I could have given you some answer of like best practices. Um, but then like if you kind of take a step back, it's like, well, then we train this model O1 end to end on reasoning. It sort of like vacuously answers a lot of these questions because you no longer have to answer them. And so I hope this is kind of like a satisfying non-answer, which is I don't know um, that we should be asking those questions generally. I think those questions should be very specific for specific use cases. And for the general case, we should try to like train end-to-end systems.
One of the things I want to mention is that there's a lot of similarity between the reasoning paradigm and in O1 and agent systems where there's multiple context windows looking at the same process, and they do go off onto these amazing tangents where they'll like go off and look at pictures of, of Yellowstone Park or something, and in the middle of trying to solve a math problem. And I guess that's not really related to either of those two issues, but I think that you know, if you search the research, there doesn't seem to be a lot, and the Auto GPT people have literally been working on this for over a year and not making much progress as far as I can tell. So thank you. I understand the source, the place your answers, as you said, non-answers came from. Much appreciated.
Okay, again, I'm going from the earliest to latest questions. Ashish is asking, OpenAI documentation suggests that number of functions should be under 10. So for the best performance, is it still the case?
Technically, yes, I might want to update that. We can definitely handle 10 at this point. I think when we wrote that, it was like 3.5 first round. I do still think that the fewer functions you have, the better it'll perform, right? Very expectedly. Um, I think you can now comfortably go up to like, I think the question is less about how many functions you have and more about like how far apart your functions are, right? Like if the uses for your functions are very clear, if your functions are very clearly named, you can go up to like, hundreds of functions. From my personal experience, I've had projects where we had a system with over 100 unique functions, all with their own parameters, and had like over like 85, 90% success rate with not that much work. And this was with GPT 3.5. So like a while ago. So I think my answer there is test it out because it'll vary a lot. It's also very, very sensitive to, well, not very, very sensitive, but it's equally sensitive to like how a human, like if you are unclear in your function naming and like the concepts that you choose to represent, and like if you allow like the function to represent invalid states, you're gonna have to deal with those. So I think all the best practices that come around writing code and defining functions actually apply to when you're defining functions for models. And the better you do, the more functions you can give it to handle. But maybe like rule of thumb, I try to keep my function like list around 10, like less than 10, but like if you have a good reason, um, you could go up to like hundreds, low hundreds. I think fine tuning goes a long way. The way we achieved such high like success rate with 3.5 was through like function fine tuning. So my answer is like test it out. It varies a lot, but definitely 10 is an outdated number.
I just put one in there that was about your demo. I was wondering, in your demo, you had your triage agent hand off to the email agent, and then the email agent said, "Can you provide me this information?" So it generated the second prompt, and I guess when you answer, you were talking directly to email agent. Now, I was wondering if that works out when the user says, "Oh, where's my mind? Can you send a text message instead?" Which would require the triage agent to now route it to a text agent, So in that, I don't know, you can explain, talk about if you can
Yeah.
handle
Is
that.
your question about like practicality or if this is possible?
Well, I was kind of actually asking about your demo and yeah, whether it can
Yeah.
handle
So, yeah.
that.
So let's do it real quick, right? So we have like a send email and that we can do like, send SMS. And now let's say like, I wouldn't do it this way, but for the purposes of this example, let's say we have like our like email agent. Like this is way overkill, but it's to demonstrate the functionality. And then we have like an SMS agent. And so your question is like, let's say I already went and I'm talking to the email agent. How do I like, could it go back and essentially retriage? Like, how would it know to do that? And
Yep.
the answer is yes. That is one case that like we wanted to handle for Klarna, so we made sure it is handled here. So my current setup is I have the two agents. I can even remove the instruction because I think that's the default. And let's give them a name. Agent. This way it'll come up in the repo. SMS agent. Great. So now I have the two agents and I have the triage, which can, let's make it be able to transfer both. Oh, I haven't defined that. Cool. I love cursor, by the way. For anybody who doesn't use it, it just always knows what you want to write. So now I have the two transfer sections, and like if I were to test this out, I can I can right off the bat say like like, I want to send an SMS. Right? It transferred me. But then if I say I want to send an email, there's like nothing for it to do. Because I haven't given it an out. So what you can do is you can have a essentially like retriage. So transfer like back to triage. User asks something that can't be done by the current agent. And so if I give this to both of my other agents, then I can do something like, I want to send an email. It's like, oh, I think I have to tell it can send emails. Instructions, you can send emails. And then I'll do the same for this, you can send SMS. This is getting a little contrived, but this is kind of like to try to show this point of like, okay, so now I can say like, I want to send an email. Great. So now I can send an email. I'm like, JK, actually want to send an SMS. So it'll transfer me back to triage. Triage will transfer me to the SMS agent, and I can do this. Was this sort of your question?
That was, and that's amazing. Yeah, and that gets to Jim's question about infinite loops now too. But yeah, that's really cool.
Yeah. The nice thing about like the transfers as function calls paradigm is it's very, very flexible. Like, I'm calling these transfer to, but the only reason I'm calling it transfer to is because like it informs the model what it should do. But this could be anything, right? Like I could say like, pass back to triage, right? There's no keywords, there's no prompts. By the way, every time Swarm like invokes the model and it returns back a set of messages, like the history that it returns is a completely valid chat completions history that you could feed directly to chat completion. So like I guess what I'm saying is like this is the whole notion of transparency. There is no magic going on behind the scenes. The only like magical step is that when a function returns instead of a string, it returns an agent. What we do in the background is take the conversation history, swap out the system prompt of the old agent, swap in the new system prompt, swapped in the new tools, and that's it. Right. And so like this lets us have no prompts, right? We don't have to deal with any prompts about like when to transfer, when to not. It's all up to the user, totally controlled up to you.
A follow-up question. So from user perspective, like how that would be, like users will interact with one agent that will delegate to other agents, or
It's up
user
to
will
you.
be interacting with multiple agents?
It's up to you. Yeah, it's up to you. So in Swarm, you do get passed between agents. And so like, let's say if I want to set up like a system like Klarna, right? Like this kind of mirrors the Klarna, where at first, let me give it a name, right? So at first I start off talking to the triage agent. And then I'm like, I want to send. Go. That wasn't English and it understood. It got confused, right? Like I'm doing a very, very poor job of like writing these prompts and everything, but the idea here is you are actually talking to different agents as defined by their prompts and like system message. Was that the question?
Yeah, I was just trying to envision the future, like as a user, how with how many agents I would be interacting, or maybe I will have one main agent, and that agent will be delegated to other agents, whatever tasks I need to accomplish, just from user
Yeah.
experience perspective.
I mean, the user doesn't even have to know they're talking to different agents, right? It could just be a matter of like loading in different prompts and, having different like routines in play. I guess for the record, like I don't think this is the solution to all multi-agent systems, right? Like I think Swarm is just like one very specific example of like simplifying this notion of handoffs. And in cases where it is highly interactive and you do sort of want to be loading in and out different amounts of like knowledge and specialization, that is not always the case. Like the example I just did would make a lot more sense with a single agent with two functions, right? This is like super, super complicated for no reason. But if you had like, if the email agent was an entire like org within the company where you like, it had to handle emails and like different kinds of email types and like had to be aware of all these different things, like then you can make one agent that's really, really good at that and not have it not like and evaluate it just on those things. This kind of lets you like partition the problem space a little bit more rather than trying to pack all the functionality into like a single component.
Yeah, gotcha. Okay, I see a question from Kartik. Kartik, do you want to ask it yourself?
Yep, sure.
Yeah, go ahead.
Great presentation and demo, by the way. Really promising package. So I think my question was primarily related to like how the prompts are created, and especially because like a lot of times I notice that you're obviously writing the Python docstring. So how does that baked how does that impact like the performance of the agent, and or how sensitive are the docstrings and like your actual code itself when it comes to like whether the agents do their whether the agents like respond correctly and whether they do their job?
Is your question on prompt engineering or how we actually turn a docstring into a prompt?
Yeah, it's more the second part, like how are you turning the docstring into the prompt, number one, and also like I guess related to that, like so I noticed like initially if you don't have the docstring, it may or may not work, or rather like including more information into your functions, into your function definition itself. Does that impact? Have you seen that to impact or improve your performance? And I guess that's related to like how you're constructing your prompts in the first place, right?
Right. Yeah. So in short, all of the text that I've written on screen is verbatim the text being passed back to the model. Like the typos you see, everything like is being sent as is. So like to kind of walk through this example. Sorry, first to answer your question, these get put in as the doc strings as part of the function schema. So like we have a little step here, function to JSON. This is just a utility function that I wrote that goes, it takes in a first class Python function object, and then outputs like a JSON schema
Okay.
in our format, right? And so like the doc string, as you can see, like literally just goes in the description. There's no like conversion, right? It's just directly plopped in there.
Okay. Okay, and so you're also doing this where you're actually looking at the variable at the types of the variables as well, right?
Yep.
Okay. Okay, cool.
Yeah, so right now, I didn't show a few things, but like I could make like body optional by giving it like a default value, right? Then it doesn't have to fill it. Or if I, say like it's an int, number, or I guess in Python it's int, it'll be a number. It's generally what you would expect it to be.
I see Eric has two questions. Eric, do you want to go?
Hi, great talk. And yeah, I was wondering, is it possible to create a survey using Swarm where basically the agent would ask a series of questions and get responses and maybe have some conditional flows?
My short answer is yes.
Okay.
I would almost recommend to start out by putting everything in one prompt. I feel like surveys are, what I would recommend is like having the function that it ultimately has to call. So if we do like, from swarm import agent, then I can say, and I can do something like, survey agent, and then I just give it one function called submit survey. And then I'll here in as parameters, I would pass the forms, the variables I want. So like name, name, last name, email, age, gender, like preference, favorite. Maybe let's make it simple right now. I can name, like favorite color, and then like an optional like, reason for being whatever. This is so funny. Why did it fill that in? Great. So now I have this function, right? And if I give it to this agent, I haven't really described anything, but maybe I can just say like, only call this when you have all information you need. Then we can test this out, right? And I could say, it's like, hi. Maybe we can tell it, ask the user questions. There we go. Hi. Do you want to give a survey? Oh, what I do? I think I'm doing something wrong.
Maybe it's expecting favorite color as an argument.
Hi. Color, red. I don't really have one. Right, so now I collected all the information conversationally, and then it submitted the survey with all the fields defined. Does that sort of answer your question?
Yes, it does. That's cool.
Cool.
I
Yeah.
had,
Sorry.
I've been using langgraph for this to create like agentic applications. And I was just wondering, I know you mentioned langgraph earlier, but I was just wondering like the key advantages of Swarm over langgraph.
It's just
Sorry.
also related to the next question from Danny, like basically, yeah, the advantages and limitations of Swarm compared to other multi-agent frameworks.
Main limitation, and I want to make this super clear, is it's not meant for production, right? Or it's not really meant as like a comprehensive library at all. It's meant for exploring like interfaces and exploring agentic setups. So, when we're comparing it against something like langgraph, which is actually a framework that is feature complete, it has all like the features that you want. I'd say like if you're going for a complex use case that you actually want to work reliably, I would point you to something like langgraph or building something yourself. I'd say as a direct comparison, the main goal of Swarm was to make it super, super easy to build these like implicit graphs with agents. Like instead of agent, you can think of like nodes, right? You could almost do like, and then just use it with nodes instead. And then you're essentially building a graph. But I wouldn't really recommend using Swarm anywhere where you're seriously using langgraph other than like, prototyping. In general, when I play with this myself, I usually tend to write a lot of these myself because I don't find that certain abstractions like I remember the original langchain, I never really understood why I needed help chaining prompts when you could just call it twice in a row in Python. I think things have changed and there's a lot of new interesting features, but to be honest, like a lot of the time I either write things myself, like the little frameworks myself to do the orchestration that I want, or I don't use any at all and just use powerful like prompts with functions because that is often all you need.
Eric, your question was about also advantages, right, of Swarm, or like potential, like where are you guys heading in the future with Swarm? What might be it?
We're not. I don't think we're going to make any changes to Swarm. I think we call this out very, very specifically in the docs. We don't have any planned work on it. I think we were trying to use it for learnings, like in case we do want to explore more in that direction. This was a sort of like test to see what the right principles are. But it's not really indicative of like any work that we have ongoing or like might do. It was more just exploration for this very specific use case. It was done by a sub-org within OpenAI on the go-to-market team, on the solutions architects team, who are really on the field with customers. So it was more an exploration in that direction, not so much like anything that we're really putting resources into as a company just yet. My personal, if I'm going to be like biased here, what I love about Swarm is that I can type a Python function and give it to it, and that it has a little REPL that you can play with. I wrote those two because I wanted them. And I had wanted them for a very, very long time. I would almost want to remove some of the agentic parts of Swarm and like just have those two features. Like I want a loop and I want my functions to be called just by typing them in. That's my two favorite features in Swarm. And if you play with it, that's really, really cool. But you can build them yourself. Like they're not simple and the code is there and you can just take it and put it into whatever you're doing. So it's MIT license. Do what you want with it.
Eric, do you have any other questions, or did we answer to your question?
Well, I just have a comment that it looks really powerful and easy to use. So I applaud your work.
This was a long time in the making. Not the framework itself, but the ideas behind the framework. I think the reason it was able to be so simple is because so many people put work into finding the right abstractions with customers in the field, and then actually putting it into like simple code was a different interesting problem. But yes, I'm quite happy with the results, even though it's not like something that we want to ship as a company. It's just a little example of what is possible.
Michael, do you want to ask your question?
Yeah, I'd be happy to. Thanks, Ilan. It's been a great talk and I've really enjoyed it. I'm from Microsoft and I work in cybersecurity, and we're working over a larger number of functions, and we have a desired output, right? We're investigating incidents and we're able to get a performance metric from it. But the agents need to take so many intermediate steps that it's then hard to know exactly how to improve that system. And so I just wanted to ask, given that you have some desired output and you're trying to optimize the system, we're relying largely on in-context learning, but we're also looking into doing supervised fine-tuning. I'm just curious on your thoughts on, as you've worked across customers, you have something, in the rare case, you have a really strong performance benchmark that you can improve on. How would you think about prioritizing the various ways to optimize that system?
It's a very broad question. I think the examples you gave are probably the direction I would explore. I think my approach personally was often trying to understand what are the steps specifically, right? Like laying out what the steps are, and then thinking like how would a human approach this problem, right? Like which steps could a human do all at once? Which steps could a human not do? Which steps could just be turned into, not a prompt, right? Like I'd recommend, if you haven't already, to check out the latency optimization guide in our docs, which sort of takes one of these examples. And I think oftentimes latency optimization techniques, like the way you analyze it, are quite similar to like just accuracy and performance in general. I'm not sure what level of advice is useful here, because we usually sit with a customer for a while, but it sounds like you're heading in the right direction. Like few shot examples are like super useful. Maybe the unintuitive or like less common advice given is like, see where you can remove a language model from the flow, right? Like see where you can like give the models less to do, and like remove steps, and just have like the necessary context, not model context, but like context variables, is my like advice. Is like, if you have a super convoluted flow, where is it really necessary? That's one. The other one is like, have a happy path that is very simple, right? If like maybe like you have a super wide variety of cases, but like 70% of them can be represented by like this two-step process. Just build that two-step process in like a semi-hard-coded way, and then have the other 30 or 20% represented by like your whole more complex triaging system. So have a happy hot path is my other piece of advice.